It is. Here we go. 4.5, Systems of Inequalities, Part A. For Part A, we're going to talk about graphing by hand, okay? Graphing systems of linear inequalities by hand. So up first, we have our, what do you call it? All right, so, yeah, number thing that I would like for you to write at the top of your paper is one of the biggest things we forget when we are solving inequalities. And you're going to write, note to self, when you divide or multiply by a negative, inequality changes. Okay, so when you divide or multiply by a negative, we'll get a new one. Inequality changes. Okay, I like to say you have to flip the switch. So step one says to solve for the inequality. So you see right here, we have 2x minus y is greater than 1. So I'm going to solve to get y by itself. So in order to get y by itself, we subtract 2x, correct? After we subtract 2x, we're left with negative y, which means I have to do what here? Divide by a negative. When I divided by a negative, notice that I went from being a greater than to being a less than, okay? The signs of everything change when you divide by a negative. So the graph that I'm now graphing is y is less than 2x minus 1. All right. Now over here, for x plus y is greater than or equal to 3, to get y by itself, I just had to do what? Minus x. Did I have to divide or multiply by a negative? No. So notice that my signs stayed the same. Got it? All right. So step one is to solve for each inequality for y. Step two is to graph your boundary lines. When you're graphing your boundary lines, you're going to be using your b, which is your slope, your y-intercept, right? So your b value and your m value to graph these lines. Your b tells you where you start. Your m tells you your directions. Correct? So for my first one, we have y is less than 2x minus 1. So its b is negative 1. So I'm going to start at negative 1. My slope is 2. So I'm going to rise 2 and run 1. Rise 2, run 1. Rise 2, run 1. Correct? To get the other side, we fall and we crawl. I fall 2, run 1, fall 2, run 1. Notice that it is a dotted dashed line. And that's because it is strictly less than. And if I'm strictly less than, then my line is going to be dashed. No, just less than, greater than. Less than or equal to is going to be a solid. Okay, solid. All right, focus, please. Next, we're at y is greater than or equal to negative x plus 3. So for this one, I begin at 3, and my slope is down 1, right 1. So I begin at 3, go down 1, right 1. Begin at 3, down 1, right 1. This time it's a solid line. Why is it a solid line? Because it's greater than or equal to. It's also defined on those points. So the line is going to be solid. You should have. Yeah. I no longer assume what you guys did in algebra. Okay. Next, we're going to do our shading. So our shading works like so. Where they overlap is your solution space. But to get to where they overlap, you're going to shade. When it's less than or equal to, you're shading below the line. When it's greater than or equal to, you're shading above the line. Okay, if you get confused, just choose the points and test it out. So for example, if I'm like, oh, I don't know what this really means. Well, if I have y is less than 2x minus 1, I can choose a point and I'm like, okay, I think I'm going below. If I choose a point below, let's say I chose 0 right here at 0, -2. If it makes a true statement, then I know I'm in the right place. If it makes a false statement, then I'm in the wrong. So if I test 0, this ordered pair is 0, -2. Agreed? So if I plug in 0 for x, that gives me what on the right side? -1. And I have -2 on the left side. Is -2 less than -1? Yes. So that's where my shading is. Okay. So if all else fails and you forget the above and below, you just choose a test point. Where the test point is true is where you're shading. Okay. All right. So I'm going to switch to my highlighters. If you don't want to use a highlighter, you can always use the horizontal vertical line method, which I will also model with the highlighters. So because I know I'm shading below this line, I'm going to shade below the line. That's the shading below. All right, on to the next one. On the next one, I'll do blue. On the next one, it says y is greater than or equal to -x3. When it's greater than, I'm going to do what? Above. So I'm shading above the solid line. So shading above this line. The vertical horizontal line method just helps you if you're not using multiple colors, by the way. Okay, where they overlap is your solution space. Do you see where they overlap? So that's why down here it says graph your solution. This is my solution space. It's where they overlap. How do we feel? Was it terrible? Yeah. All right, so we're going to do example 2 together. Then you're going to do example 3 and 4 at your table and we'll check. Cool? All right. Here we go. So starting from scratch with example 2. So I have, are my y's by themselves? Yep. Yes, so y is less than or equal to x, and y is greater than or equal to 3x minus 1. Step 2 is I'm going to use my slopes and my y-intercept to start. So my y-intercept for my first one is 0. The slope is 1. Make sense? It is equal to, so I know I'm going to have a positive solid line. Yes? So I'm going to go to 0. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Nope. I just got to do a bunch so I can try to draw a straight line. Keyword is try. All right. How do we feel about line 1? Okay. Line 2, our b equals -1. Our m equals 3 over 1. Based on what we have here, we're going to have a solid because it's equal to, and it's going to be a positive line. Yes? Yeah. So I'm going to start at -1. At -1, I'm going to rise 3 and run 1. 1, 2, 3. 1, 2, 3. 1, 2, 3. And then I'm going to fall and crawl. 1, 2, 3. 1, 2, 3. 1, 2, 3. And I'm going to do my very, very best. You start at -1. Your B is where you begin. All right, so now we're going to do our shading. So step 3 is when you shade. So step 3, for the first equation, it is greater than, less than, right? So for the first equation, we are shading below, and that's because it's less than or equal to. Agreed? So my red one, I'm going to shade below. I don't feel like shading, so I'm just going to do the vertical lines. Shading has been taking place. Okay. For my blue, it's going to be shaded above because it's greater than or equal to. Do we see that? So I'm going to shade above the blue line. And where do my two intersect?
Right here in the third quadrant.
Down in the third quadrant. Good job, Randy. That is my solution.
Wait, so how do you
That means that any number, well, any ordered pair in this shaded region will satisfy that system. Does that make sense? So any,
how do you do above? Because like I'm confused, you said above the blue line.
okay, so remember we said if you aren't comfortable with where you're selecting as above and below, you just choose a point and test it out. So if I'm trying to decide if this is a good spot, I'm going to go to 0 because it's 0, right? And I'm going to choose here, right? I'm going to test 0, 2, and see if that's true, right? So if I plug in 0 and 2, if I plug 0 into here, that gives me what?
It would be or two.
No, 0 minus 1 is
Oh.
-1, right? And is 2 greater than -1?
Yeah.
So then, therefore, this is the correct space. If it makes a true statement, then that's the space that I'm using. It's always good to test it with zeros, just for the math purpose. Okay. All right. I'm going to give you, let's say, 2 minutes to do example 3 at your tables and check each other. And then we will check as a class. And I'll be around to help. Cool? All right. So y'all are on example 3. Here we go. So step one was to get y by itself. So you got y by itself on the first one. You got y is greater than negative 2x plus 3. Agree? On the second one, you had to divide by a negative. So it also became y is greater than, correct? And you got x minus 2. Yes? All right, step 2 is to graph these bad boys. So we're going to graph them, and they both are going to be dashed lines. One is a decreasing dash line, and the other one is a increasing dash line, correct? So I'm going to go to 3. 1, 2, 3. And my slope is down 2 over 1. 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 And then the other one is going to be up 2 over 1. Up 2. Up 2 over 1. Up 2 over 1. So there is my, okay, yes. On the second one, we're going to start at negative 2. So we start at negative 2. This time the slope is 1, 1. Up 1 over 1, up 1 over 1, up 1 over 1. You get it? Down 1 over 1, down 1 over 1, down 1 over 1. You get it? So I'm going to draw my dashed lines. They are both dashed. All right, step 2 is done. Step 3 is to do your shading. So for the first one, I am above. Also for the second one, I am above, above, above. Let me go to my highlighter. So I'm going to be shaded above. So this one is shaded above. Above, 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 above. Okay. The other one is also shaded above. 10 that these are some good shading for you. Where my shading overlaps is my solution space. Do we clearly see where they're overlapping? You can't see where it overlaps. Just to be difficult. What that means is that any ordered pair in this area will satisfy the system. Okay. So that's what your 3 should have, final solution should have looked like. I said, or you could do the lines. All right. 2 minutes to do this one, and then we'll check, and we're done for the day. Yes. Yeah. All right, we'll finish this later or resume this later.